Good evening, everybody, and bees all day. It's another Monday night. It's getting cooler outside. Winter's starting to set in here in the mid-Atlantic states. I'm sure up north it's getting cooler. I was in North Carolina today and it was 65 degrees. I couldn't believe it. So I'd like to welcome Zac Llamas tonight, and he's a researcher at UMBC. He was with USDA. He still is until February. And he's going to talk about some of the future research that he's going to be doing. And if you have questions, you can feel free to come in. The link is pinned at the top and ask him your question, or you can put it in the chat, and we'll do our best to get his attention so he can answer that. So Zac, go ahead.
All right. Well, Bill, Charlie, thanks for having me on here. This is great. And anytime we can set aside a couple hours and talk to beekeepers and talk shop, it's fantastic for me and hopefully fantastic for everyone else. I think the worst thing about hearing me talk is you hear it over and over and over again. I talk essentially about varroa and viruses more than anything else. And I'm kind of getting sick of myself talking at this point about that one subject because we have other things in beekeepers we have to start addressing. One of them is this pesticide exposure. It's a big deal for beekeepers across the country, especially if they're in regions where they're surrounded by ag. And we also have the fact that we're having a lot of land use change in our country. So we're seeing what used to be really great bee forage areas get turned over either for urban development or into row crops that are kind of encroaching on pasture land. So this is a big deal for beekeepers, in terms of abiotic exposures and also seeing our carrying capacity disappear a little bit. And then eventually we got to get back to talking what we really like to talk about. Rearing queens, making splits, making a big bumper honey crop. And that's the fun stuff we're supposed to be talking about all the time. And it feels like it's the last thing we actually talk about. But anyways, my name's Zac Llamas. I used to have a small migratory operation and I worked for Mike Palmer up on the Canadian border. And then at one point, my business got to a point where I could stop working for Mike and stop doing roofing in the winter down in North Carolina and kind of scale up my operation. But I knew like once I started making hires or leased a warehouse, that's all I would do. And I had this inkling for a while that I wanted to go back to school. And I was actually down in North Carolina over near Wilmington, and Don Hopkins, the state inspector down there, was inspecting my colonies one spring before I moved them up. And I was chatting about wanting to go back to school. And he made a comment. He goes, "I've seen you go from 3 colonies to 400. You can always do that again. You'll never go back to school." And I'm real happy I had that conversation with Don. It took me about a year and a half to actually get into a program, which is not the easiest thing. I say most students take a gap year between their undergrad and their graduate school. I took a gap decade. So I had some upstream waters to navigate to actually get in a program. But I'm real happy I did. And I actually have just one question I wanted to answer, which is how can so few mites be so devastating on a populous honeybee colony? In some ways, it doesn't make sense. They're telling us 3 mites out of 100 can kill your whole colony. And I wanted to know mechanistically how that could occur. And I'm so glad I went back to grad school because that 4 years and then my postdocs afterwards have just been this lucrative discovery in how varroa are transmitting viruses and how those viruses are moving from bee to bee and how they ultimately can cause your colony to loss. I've also had the incredible privilege while being at the Bee Research Lab in Beltsville, Maryland, to respond to beekeepers when we have severe loss events. And there we're both to do not viral and pathogen discovery, but we're also able to do pesticide discovery. And that's been an incredible service to beekeepers. So Bill and Charlie, I'll hand it right back to you, but thanks for letting me give my own introduction.
Yeah.
Well, yeah. Go ahead, Bill.
Go ahead, Charlie.
Well, I mean, I know that Zac here has been actually at my club, Susquehanna Beekeepers in Harford County, Maryland, several years back. And that's something new for me. As we were talking just a little bit previous going on live, is about we've been hammering the mites for for at least 10 years or more. But there hasn't been a whole lot that I know of about viral loads and what we as beekeepers can do. I've just started. There was one video that Bob Binney put out here about 4 weeks ago. PhD down in Georgia, Dr. Meyer or something like that, I believe. I'm not sure. Anyway, he was talking about microbials and helping out possibly the bee gut, which in turns, that's how I think the bees actually mitigate the viral loads and for their defense mechanism. You can tell me more about that, but I'm looking at, okay, does super DFM possibly help, that part of it, and that kind of thing. I guess that's, you can maybe hopefully tell me about that, Zach.
There's, as soon as we start talking about one thing in science, we can go deep into that real quick. And you touched on a few different things there. So gut microbiota is actually something I don't study very much. And it's its own animal in terms of the depth of research there. But it is a complex thing. And your bees have this extra organ that we don't always talk about much, which are all of these bacteria that are colonizing their midgut and provide essential functions to the bee, just like we do as people. We have our gut flora, which we actually talk about. And we know when it gets out of whack, we can do it pretty easily by either consuming too much of the wrong foods or consuming foods that are, on individuals we don't always digest very well, right? But we also have these exposures that can really throw it off. Well, if you look at some of like Nancy Moran's work, if people watching here really want to jump into some of the scientific literature, you can always type that into like Google Scholar, Nancy Moran, Moran, and just a wealth of information on the gut microbiota, how pesticides can perturb it, or interactions with viruses. I will say that if we can fortify a honeybee, so Charlie, you're bringing it up nutritionally,
Right.
definitely does help with them dealing with viruses. And yeah.
So, that's something that I've been interested in here recently. And then, of course, your viral, or not so much your viral loads, but you got your mite loads. And I think I do a pretty good job of that. I mean, when it comes to my mite protocol, I guess you would call it. Well, last year we did Aprivar, and then I'm sure Sybil. She came in, and I participated in the National Honeybee Survey, and you probably even worked on some of that stuff down there at Beltsville. But anyway, the Aprivar just didn't work. You could physically see the overload of mites, and she was there right at the end of the 6 week of that product. I backed it up with Formic Pro and then oxalic acid vapor throughout the winter time, about every 2 weeks, and got them all under control. And then this year I switched over to Aprigard and then Formic Pro, and then now oxalic acid. And my mite drops as far as underneath the chloroplast board, or some people call it the sticky board, last week was pretty much zeros, except for one mite I found. So I'm actually about 6 weeks ahead of what I was last year because of that one product not working. And so I think, as far as mite load, I'm in good shape and everything. And I think a key, something that I started, was starting to do OA vapor throughout the winter time, as long as it's about 48 degrees. It seems to keep that mite load suppressed throughout the winter time. And then I don't do any treatments while the honey season, which is April, May, and June for me.
Yeah.
And that kind of thing. So that's what I've been doing, and it seems to be working. My only other thing is, now you obviously have done queens and stuff. I think I think that I've been working on queens for the last 2 years. I had issues 2 years ago, put all brand new queens in, had made a great honey crop. This year I was researching it and listened to one of the lady, a PhD out of Texas, ANU, stated that after the first year, that queen, the second year queen, she loses about 40% of her laying power.
Mm.
And to me, that's huge. And I do a rolling demery for honey production increased and all. And I think I actually personally burn that queen out faster. I probably have a 50 or 60% reduction in brood rearing on that queen. It's a second-year-old girl. So now I've learned what the commercial guys have already known. You requeen every year, to increase much financial, honey production out of the hives as you can through, more worker bees in the hive, from what I gather. So, I mean, you've been there. You actually, you were saying you had 400 hives. You were what, doing pollination services or honey?
No, actually, I made so much from selling nukes
Okay.
in the spring, and then a honey crop, recovering, and then doing a honey crop up in New York, that I never did pollination. And that was my decision. And it worked out real well because I can get a pretty easy winter on the coast of North Carolina. And at the time, my earliest grafting date was something like February 26th or something like that.
Wow.
Yeah, it usually it'd be like
Early.
usually around second week of March, and make quite a few nukes, flip them, and then just go up to New York with these singles and a half and super them right up. And that was excellent. And I was doing that while working for Mike. So I think the biggest, actually, I tell people this, is the biggest mistake I think I made in terms of business is not having business acumen and knowing actually how to scale. I thought at the time scaling meant working harder. And that is definitely not what it means to grow up, to grow a
No,
company.
it doesn't.
But it's definitely not. And one of the things I learned though in that was when you requeen on a schedule, it helps you on their business end. You might have a queen that you love and she's getting into a year and a half, but she's likely to fail at some point in that second year. So if you have queens all over the place failing at different times, it can be real difficult to do your management because you're constantly playing catch up and doing requeening.
Yeah, that's my problem.
Yeah.
And my thing is, it seems like I'm always putting out fires, spot fires and everything.
Yeah. And
when it comes to queens,
then the contrast between my regimen and Charlie's is Charlie and I are together in the winter, but I don't wait for it to get 40 degrees. I'm going to vaporize them twice in December, twice in January, and once in February. And then in the spring, early spring, when temperatures are above 50, I'll throw one pad of formic on there and then do a mite wash.
Yeah.
And then I treat again in August with Apigard. And then I treat again in the fall with Formic Pro. In September, October, I'll treat again. Do a mite wash first, and then see what the mite load is, and then treat again. Typically, when I've gotten inspections done in the past from a state, they've been a 0 or a 1. So, and I try to keep it there year round.
Yeah.
So,
that's Tom and Melissa's got a question here.
Yeah, Tom and Melissa want to know if you have any graphs that show mite load increases, and so do the virals.
Yeah, that's a great question. So I don't, and not prepared for today. I do have slides prepared for Bill here to give a mite talk on some of the work I've done, but we get a lot of noise in field sampling, and it's one of the frustrating things for researchers and extension is we don't always see a great correlation between mite loads and certain viruses. What we do tend to see though is the seasonality of viruses. We're early in the season. We see these non-vector-borne viruses at pretty high levels. So sac-brood virus, black queen cell virus, especially the lake cyanides, right? And this is where you'll typically see nosema at pretty high levels. Obviously not a virus. And then as we get into the late summer into fall, this is where we see those vector-borne viruses pop up. So deformed wing virus A and deformed wing virus B. And in the case of recent years, we're seeing paralytic virus like ABPV pop up. And especially the last two, deformed wing virus B and ABPV, which is acute bee paralysis virus. You don't want those two popping up. Our bees do very horribly with those two, especially when a mite is able to feed on a bee and vector it directly into their hemolymph.
Okay.
And
Roy's got a question. What kind of requeening timeline for 400 hives?
Yeah, that's a great question, Roy. So let me talk about the mistakes that I made first, because I had this idea that I could do individual management as I was approaching 400 colonies. And that's not real possible. You got to get onto a schedule and start systematically managing these colonies. And so the easiest way for me to do that was to do all of my spring splits. Again, I said I make most of my income from nukes that I'm breaking down off my parent colonies. And this is in March, early April down in eastern North Carolina. And then what I would do is I do another round of cells, and I would go through and requeen before I went up to New York. That way I was going to upstate New York with all new queens. That was my ideal. Of course, it would get behind. You'd always get a pod where, weather was horrible, or again, I was thinking that working harder and harder was how you grow a business. So I wasn't hiring in the seasonal help that I should have. Ironically, I probably would have been more profitable doing that. And so that's my ideal, is getting into upstate New York where everything's already requeened there. So that's on a yearly cycle then. And other than your labor, requeening with cells in your own operation can be pretty profitable or pretty low cost.
So you're going to requeen all 400 hives every spring then, correct?
Yeah, roughly. And I should say that's what I got up to. I finally got down to about 250, and that was actually far more profitable for me.
Yeah, but I mean that's that situation there is like I got 26 hives right now. I used to have more, but I'm downsized. But I want to requeen. So you're saying to requeen early, drop the cells in, pull the old girls out in nukes or whatever, and sell them, and do it that way. Then, as far as a business model, I guess you would call it, or requeening model.
Yeah, if someone was asking me about your schedule, that's generally what it was for me, was requeening before going upstate to New York.
Of course, you're also in the South, and it was warmer too.
No, it's prime bee season then, April on the coast of North Carolina. In fact, when you're down there on a great honey flow working your colonies, you're wondering why you would go anywhere else on Earth. I mean, I made nukes down there before and just left honey supers vertical, and they don't get robbed out because there's so much of a flow coming in. And
Really?
Rob just disappeared. I thought he was just on here and say hi.
Yeah, he's been in twice, so
He's having a connection problem.
Oh, that was it. Okay, I felt horrible not saying hi to him. But I think what we should really mention. Okay, Rob, before you disappear again, hi. Good to see you.
Third time's a charm, Rob.
Yeah, that's what I'm saying.
Don't do that without letting me say hi. But I think what we should really mention for audience members, if you're not running a lot of colonies, or if you're not struggling with your labor with your colonies, you can do that individual management, especially if you're okay with it. You've got a half dozen colonies and you want to let a queen ride out maybe longer into her life than what would occur on a strict requeening schedule. That's a totally fine way to go about it. But what I would do is learn to be a little apathetic. She's getting on, or you're starting to see signs that maybe she's fading. Don't wait for it to actually occur. You're going to have a dead colony in late fall or winter. Actually do that requeening ahead of time. And we nurture our bees, we take care of them. And if you're not real familiar with this, that's going to, you got to develop a little thick skin and then do that.
Yeah, Zach, that's what I found with that second year girl that my management model, I want her to lay up the whole entire brood box in that single brood box. So all the honey goes upstairs and minimal amounts in the bottom. And I found after the second year that her reduction in brood rearing, there was more honey down in the bottom. And you could just see there wasn't corner to corner, slabs of brood on the frames and stuff like that. And I'm like, okay, I can definitely tell, evaluate that queen, that we need to get rid of her. She's fading, is like you said, and all. So introduction, everybody here. Zach, this is Brian. Out Flower Street Farms is his thing, and he normally lives in Colorado.
Hey,
And
Dr. Zach.
Tom lives out in St. Louis, and they have. And let's see, Brian, you got what, 75 hives, and Tom, you're what, around 200 and some, and all that, and
Yep.
So, and then of course Rob, he's got what, 400 hives, Rob?
Around about, hope to stay around 300.
300, something like that. So,
So when are you leaving for almonds, Rob?
I just found out today that they want us to send them out the second week of January.
Cool. So Zach, I have a question for you.
Okay.
The mite loads that you see, I'm going to say, use the example of June. Okay. So if you see a mite load in June, doing an inspection, you do a mite wash, and you get a high mite load, and you treat that high mite load, and you knock it down to 0, 1, 2, whatever, down those low numbers like that, low percentages. How soon after you knock that down are you going to start seeing the effects of the viral load?
Oh, that is really such a great question. One, if I could see the effects of a viral load with precision, I'd be real wealthy. I'd just be in the upper Midwest in the summer, looking inside people's colonies and doing consulting. But that is the scenario pointed out there I love, because this is a great question for mid-Atlantic beekeepers. In June, a lot of us, our honey flow is going to be finishing up, right? We had a real strong honey flow. A lot of places are going to get into dearth. You're going to be lucky in areas like this, especially like some of these areas around like Beltsville and College Park and Silver Spring, Maryland. And they'll have a trickle flow coming in. But the most of your honey crop's already on that colony. You can get those honey supers off. And in a scenario like this, I really encourage it, because those supers are off. You've got a condensed colony now, and you can treat it as you described. But think of what's happening there at that time. Your colony is still producing quite a few drones. And if any of you watched my research or read any of the stuff I've done, you know that I focus on drones so much because when they're populous in a honeybee colony, Varroa are feeding on them. Okay, so when they're feeding on drone brood and adult drones, they're not as high of a level feeding on those worker bees. Well, that matters. We're interested in the viruses, right? So what do drones do inside the colony? They don't take care of the queen, they don't rear brood, and when they engage in trophallaxis, they only receive, they don't donate. They're a really poor candidate for secondary transmission of viruses. And that's where all the bites are occurring on those drones. Think of them as a sponge. They're really this cushion just absorbing the impacts of Varroa when they're really present. So you notice that then, and then treat it and get it way down below threshold. Good for you. What did you do? You prevented your worker bee cohort from taking all of these mite bites for the rest of June, for the rest of July, for the rest of August. Then you're going to have high viral loads, because what's going to happen is eventually you're going to get this viral amplification of worker bees. You nipped that beforehand. That's good for you. And every treatment schedule that I recommend, you always hear me say, manage the mites before they impact your worker bees. And what you just described right there is fundamentally what small scale and backyard beekeepers should be doing, which is noticing when they're ticking up before they move on to the worker bees and manage those mites right away. I love that question.
The thing that I see though in the backyard beekeepers, especially here in the Shenandoah Valley of Virginia, is that they've been trained to use one treatment a year. They don't rotate treatments. And if they use the one treatment a year, it's the oxalic acid dribble in December, which is not the correct time of year to do the dribble if you're going to do it. You need to do it when you can break that hive apart and do the complete hive.
Yeah.
I've talked till I'm blue in the face about that. And I've talked till I'm blue in the face about rotating treatments throughout the year instead of using one and relying on just one.
All right. So, Zach, you're saying that the mites are biting the drones. All right. What I'm getting at is I got drone frame in my hives. One, they give a place for the queen to lay drones. So you don't have so much burr comb in there between the frames of drone brood. And also I use it, I need the drones for mating because I do rear queens. So, I mean, there's a lot of guys, I say, oh, you got to pull your drone frames out and kill them. And that way you reduce your mite load and whatever. So are you saying, is it good to have the drone frames in or not?
Well, Charlie, whether you like it or not, your colony is going to make drone cells. Even if you try to keep the cleanest foundation frames that you can, they'll put it somewhere. It's the time of the year they're investing in sexual reproduction. They're going to do it hell or high water. But those drone combs do something for you. It's a temporary reservoir that can trap varroa. I'm getting some feedback. So it's excellent for drone comb removal as a management strategy. But also when those drones are in there and the mites are feeding on them, they're simply not impacting the worker bee cohort nearly as much. There is a problem, though, with keeping those drones the way you're describing without taking them out. Is mite reproduction on drone brood is incredible. They get a 3-to-1, right? Foundress goes in, she comes out 15 days later, she's got 3 daughters. Now instead of 1 mite, you got 4. That's a really bad equation for a honeybee colony where they're doing that cycling a couple times a month in that drone brood. And that's where we can get those thousands and thousands of mites at the end of the season.
Okay.
Hey, Zach, what have you found with talking about drones? And it sounds like that's one of your favorite topics. I've heard a little bit more chatter here in the last couple years talking about the effects of herbicides, pesticides on viable sperm within the drones. Do you have, I can imagine you have a lot of experience there. Can you maybe talk a little bit about that and what you have found?
Yeah, I actually haven't. So the only time I looked at sperm viability, it was for focused solely on varroa parasitism and viruses. I hadn't looked at pesticide affecting sperm viability. And one reason being is University of British Columbia and North Carolina State, they're doing some incredible work with drone fertility, right? When you have some people that are excellent and domain experts at doing something, tend not to move into that direction simply because it might not be the best use of my resources and our resources, right? And I would say, so I don't know much about that. And I'm trying to point out a couple labs that if you're really interested in something like that, maybe reach out to them. But the drone sperm viability, man, that's something else. We did an experiment, and this was a great learning experience for me because it was a lot of work. But we had such low sperm viability in all of our drones, even our controls, that we realized our sample size had to be like 5 times higher than it was, just to have the statistical power to make an analysis. And that was frustrating. So it's astonishing that you'll get these drones, they're buzzy, they're going on their flights, they're coming back, they're going back out. We grab them, we'll invert them in the lab, and we'll do a draw. And we save some of that for viral analysis. We save some of it for sperm viability, and they're all shooting blanks. And it's just incredible when you see that.
Yeah. Well, I only bring this up because I think sometimes as beekeepers, we can focus on 1 or 2 things, but we miss out on sometimes the larger picture. And that's the reason I ask about that. So if we have a strong colony producing lots of drones, but let's just for numbers sake and just for argument, say 2 out of every 3rd drone has a very slow or low sperm count. I mean, we're not really doing good in that regard. So that's kind of why I asked the question.
Yeah.
It's just in order to have well-mated queens. I mean, we really want those queens having a very diverse opportunity to mate with as many drones as possible. So we don't have to worry about a queen failing mid to late summer. And now you have a timing that you're trying to requeen, say, late in the year. And it's just probably not going to happen, So we worked really hard throughout the year to make sure we've got our mite loads in check and X, Y, and Z. But if we end up with some very poorly mated queens because of, I don't know, let's just say potentially weather conditions, timing on that, but also even the potential of, some other outside factors in there, affecting the sperm viability, we end up in the same boat with a very, very poor queen and a collapsing colony that we may not be able to do much with.
Yeah, I mean, I luckily the picture's not as stark as we're describing, because we all successfully made a lot of queens. It's the question of, how many of them get poor mating and how much of it's contributed to what we're talking about here, which is drones with poor sperm viability. And I don't know. But we do have an issue with quick failing queens, and definitely something as an industry we want to figure out, because let's face it here, she has, as a singular bee, an outweighed impact on the life outcome of that colony. So if we identify a hazard that's impacting queens, whether it's indirectly, let's say you brought up an abiotic potential exposure affecting drones, thus affecting a queen, that's a big interest for the industry, right? If it turns out that it's something else, let's say viral load in drones, then how do we address that? Is it through developing antivirals? Is it really working on getting our mites under control well prior to the mating season? Don't know.
Yeah.
That's I love that question.
I've noticed here in the Shenandoah Valley in the last 3-4 years that about 2 or 3 out of every 10 queens that I raised come back and they're not well bred.
How do you know they're not well bred, out of curiosity?
Because what we do is we leave them in a nuke for 2 to 3 weeks before we'll pull them out of the nuke and let them lay. And they never really get beyond a shotgun pattern.
Gotcha. And out of curiosity, so Katie Lee did this really incredible experiment. So Katie Lee up in Minnesota. Oh man, the names are all gone. I think your name's Tim in the center. You're nodding your head. Or Brian. Yeah. And he's got it. She switched queens.
Queens between colonies. Yeah.
Yeah. And the brood pattern would recover. Is that correct, Brian? Is that how it went?
Yeah, so essentially the conclusion was it's just as much environmental conditions of the colony as the quality of mating of the queens that are factors.
Yeah, and that's why I'm jumping right in saying, well, how do you know it's the queen? Because there are so many factors involved with that spotty pattern that that makes the research kind of complicated, and I'm curious. Yeah,
I mean, I can take her out, squish her. A week later, put another cell or another virgin in that hive to go out and get mated and come back. And when she comes back, she'll lay a perfect pattern in the same one that I had a queen in there. It never really got beyond a shotgun pattern.
Okay. Well, if it's from the queen, that's a great find for you, so you can eliminate them. For me, I worry about abiotic exposures, so some sort of pesticide exposure usually causing poor brood patterns, or I always worry about having a brood disease, because we have some great hygienic bees now, and they'll remove a lot of that real quick before you can see the symptoms. And stuff like EFB and chalk, I do not want it around in my research apiaries. They're horrible. They can ruin an experiment. And if I go back to selling nukes, I can't sell nukes that end up breaking out with something after someone's bought it. It's going to ruin my reputation and be horrible for my customer. And,
Yeah.
and worse would be if they're a first-year beekeeper and they get a horrible first-year experience. That'd be horrible.
Yeah.
Yeah, I'm glad you mentioned that, Zach, because as I've been the last 3-4 years really getting hardcore into the queen breeding, I've noticed that you can't judge a colony just because she has a solid brood pattern. When you got a super hygienic colony, that colony will always have a shotgun pattern, and we've talked about Corey Stevens. I mentioned here weeks ago, I think, about the colony that I had this past year, that it just looked horrible. I thought extremely mite disease. We called in the state apiarist. They came out. We washed. That colony's never been treated. We've never got more than 2 mites out of the colony on any wash. Never got fed. It's going into winter with a second box on it. And it's done everything by itself the whole way through. And everyone's saying she's just super hygienic. And, we even pulled full sheets of brood out of another colony, stuck it in there, pulled it out 24 hours later, and they shredded 50% of the brood. So, it's a genetic thing in some cases, not every case, but you can't judge a book by the cover.
Yeah, sometimes. Yeah. Story.
Charlie, you mentioned about the requeening and stuff like that. Something also I've learned from Corey Stevens is the importance of pulling out bottom feeders. Everyone thinks that you have to always go and continue to put better queens, but if you allow these bottom feeders in there that they just never build up, they don't produce honey, they can't control mites, and you let them out there, you're putting those drones from those colonies, in your DCAs as well, which eventually passes on to, your next generation of queens. And, Corey, he basically used the illustration of like a baseball team. If, you can have a guy who can throw a lot of strikeouts, but if you don't have anybody on there that can bat, or you got an outfielder that drops every fly ball that comes to him, you're not going to win very many games. And so he stressed the importance of not only, having the good queens and good genetics, also stressed the factor of taking duds out of there as soon as you recognize they're a dud and pinching them and replacing them right away. And even Megan Milbrath, her and I talked a couple of years back, and that was one of the things she said is you got to get used to killing queens if they're junk. Like, they're not worth the work. If you got a colony that you're continually feeding brood to get it to build up, she said, you're defeating the purpose.
Yeah, I've never done that. We're back to the drone thing and the viability of the drone sperm. I had heard here recently that if you do like spring miticides, that seems to affect the drone sperm as far as being not efficient as far as spring mating and everything. Have you did any research there with that kind of stuff, Zach?
No, actually, you're asking stuff outside of what I do, but that's fascinating. With you for drones, most of what I focus is on is mites feeding on them. All
right, mites.
That area. Yeah.
Hey, Zach, maybe now's a good jump off spot. Tell everybody about, because not everyone probably on here knows really much about you. Can you just give a little bio, what kind of research you have done and what you're, stretching out with the new Bee Lab?
Yeah, definitely. And then I should just double check before what I talk about. Should I share my slides at some point today, or is that not a thing?
Please
Okay.
do.
So I'll do an intro now, and then it'll be a little redundant with the slides. But Rob, when I first got on, I made this comment that when I was running my operation, it was a small migratory, I had gotten to a point where I could either scale up and make hires and stop working for Mike and stop doing roofing in the winter, or I could go back to school. And I chose, obviously, to go back to school. And there was one question I wanted to know, which is how are so few mites able to kill a populous honeybee colony? Because to me, it didn't make sense at the time. How can 3 mites per 100 bees be a threshold, right? So when I started my PhD, I was out of school for 10 years. I had to figure out a lot of stuff, kind of get used to being back in academia. And I mean, I think the first meeting I showed up with, I was grafting queens in my backyard before a Monday 8 a.m. meeting. So I showed up and I had smoke or soot on my hand, and I was kind of tired and I kind of had to get used to being in academia. But all I did was follow mites, like literally watch individual mites and what were individual mites doing. And this is kind of easy. We all know how to mark queens. So I would mark a bunch of workers and put them in these plastic cups in the laboratory and add just one mite. And I would watch it. I would just watch what they were doing. And I started noticing, oh, they're not staying on the purple bee the whole time. They're moving on to the yellow bee, or they're moving on to the orange bee. So I set up a pretty big experiment and would track them every 12 hours. Which mites are they feeding on, or which bees are they feeding on? What are they doing? As simple as that experiment just sounded, it was a wealth of information, and started to see that these mites are super mobile on your adult bees. They actually move from worker to worker to worker in order to feed. Now, some of them barely switch. They'll stay on the same bee for 2 weeks. And then others will switch to 2 bees a day for a short period of time. And this is also why the bee research laboratory at Beltsville, Maryland is just phenomenal. I was visiting there and spending a lot of my time while I was doing my PhD there. And there was this guy, Matt Heerman. He's unfortunately passed away, but he was an incredible guy. And I was describing the work, and he goes, "Have you ever checked out vector capacity in mosquitoes?" And I go, "No." And he's like, "Well, go check it out." And Matt was kind of crusty. He was really great like that. He would just kind of gnarl some good information at you, and then go on and doing his own thing. And so I went on Google that night and I started looking up vectorial capacity for mosquitoes. And oh my gosh, guys, there's an incredible wealth of vector biology work that's already been done in mosquitoes, because they impact human health so much, that we've never applied to honeybees. And all I did, my work just shifted right from there. Where what I did was I looked at the wealth of work already done in mosquitoes and started applying it to the honeybee. And some of the biggest findings I have are that model. They move from host to host in order to feed, and they do it with this huge heterogeneity between individuals. Well, that's really cool, because in mosquito biology, the mosquito that switches host the most, it's most likely to feed on an infectious host and become infectious itself. So Varroa are doing the same thing. We also see in mosquitoes and ticks that when two feed on the host at the same time, a naive mosquito can become infectious if it's feeding on the same host as an infectious one. And this is something that everyone in the audience should actually know. Not all of your mites have virus in them, right? Especially early in the season, you've got a lot of naive mites, meaning they're a vector, so they're a biting arthropod. They can essentially spit virus into a bee when they feed upon it, but saliva. But a lot of them don't have deformed wing virus, or enough of it to actually transmit and cause an infection. Those are called naive. Man, you take two mites, put them on the same bee, and allow them to feed, they both leave as infectious, right? That was lifted from tick and mosquito biology. And then when the pandemic hit and the lab shut down, man, I couldn't get into the laboratories. And I got this amazing fellowship from Project AFSM. They gave me $150,000 to pursue this work. And I had come with tons of field experience into the University of Maryland. So everyone was trying to get me to do field work. Essentially you don't have to train me. And, I know how to kind of work out in hot weather without getting sick. And if my truck gets stuck, I know who to call or how to not get it stuck in the beginning, right? And I'm like, no, as soon as you guys put me into field work, I'm going to get pigeonholed there. And I'm going to be stuck doing field work for my whole PhD. I didn't want that. If I want to do field work, I could keep doing it on my own. And so I wrote this whole fellowship to be nothing but lab work. I wanted to become a molecular biologist. And then COVID comes around and all the labs shut down, right? So that was kind of horrible. But I had just read this short article in Science Magazine on how parasites prefer males. And I thought that was kind of interesting, right? And then I was looking up mosquitoes and how they'll feed on males more often than women. Some of it's because males, sometimes we're just stupid, right? Like you shouldn't in certain areas really go out when mosquitoes are biting. So that's around dusk. And of course, guys will just do that. So some of it's because of the host, not just because of the mosquito. So I went out to my backyard and with my queen marking pens, right? And I painted a bunch of workers as they emerged and a bunch of drones. and just a bunch of different colors and recorded them. And I went back inside, and when I came out the next day, I started picking up the bees that I had marked. And a bunch of them I marked the previous day, they had no mites on them. Suddenly I'm picking up workers, and one gained a mite, most of them have nothing. I start picking up the drones, and mites had just moved on those drones overnight. And I was picking up drones, and they have like 8 mites on them. And suddenly there was this huge finding where it's like, oh my goodness, we've overlooked this for years. And so a lot of my work, Rob, is just following individual mites and then seeing how does this fit into vector biology or disease ecology, right? So fundamentally, I want to know what behaviors Varroa are engaging in. And when we identify a behavior of interest, we then ask, how does it drive viral transmission? And this has been a lucrative area of scientific inquiry. There's just a big gap in knowledge, and I've been able to go into it.
Wow.
I heard you or saw some of your presentation down at the South Carolina Bee Conference, I think 2 years ago, Zach, and it blew my mind. I couldn't believe it changed. And I don't know if you remember this. I told you I'd met you, and you probably don't remember that. But at the end of the day, you shared there about how that transmission worked, where a mite that could be viral could feed on a bee, give it to a bee, and then another might feed on that bee, and now that mite becomes viral. And then you eventually shared how through trophallaxis, so that one bee who now has that virus is going to feed another bee, and now it's transferred again. And I've seen this like superstorm. And I'm thinking, no wonder the colony can collapse in a matter of weeks, because the transmission is just happening so stinking fast in the colony. It just made sense. And I had never had anyone explain it or teach that at all at any level. But it totally makes sense, when you see this just pumping strong colony in July, and then in August, you just got this tremendous crash. And I could not wrap my mind around it. And I thought, holy mackerel, I just cannot believe this. I went away changed. I mean, like my whole management plan just absolutely just changed overnight on knocking down mites, and a little load is too heavy of a load and all that kind of stuff. So I mean, like, and so I became a big fan right away, and so like I say, just as simple as that. But and I know you're doing a whole lot more research, and you just came California?
Yeah, from a meeting.
Yeah, and then I was shocked. I seen you were and then you were in New York, because you just got home, right?
I just got home. Yeah, it was a good little trip. So I've been doing a few talks. Yep. Yeah, but Rob, I really appreciate that story. That's also part of the point of the work and presenting was, I don't know about you all, but I kind of hate when people tell me what to do. And it didn't really make sense as a researcher to try to start telling beekeepers what they should do. And I thought one of the most efficacious things would be is if we just describe what Varroa are doing. Y'all have supercomputers in your head. I mean, we all have tons of experiences. When we're in this many callings, we start to describe in detail what Varroa are doing. In your head, you're suddenly starting to construct your own management. And that is what we wanted, was to describe it and you to go, this is when I need to treat. This is when I need to manage. This is when I need to cult callings. So I love hearing that.
I think that's funny you bring that up, Zach. Not like being told what to do. That's probably why I've owned my own company now for 25 years. But I think with fairly good certainty, probably most of the guys that you're seeing in this chat right here are very forward-thinking individuals and don't necessarily like being told what to do. Probably more so would rather be giving some education and let us figure it out for ourselves. But I'm also going to tell the flip side of that story is there's a gentleman that's from St. Louis. You may know him, Jim Masucci. He was he is a molecular biologist actually, and he worked on the field studies and the research here for Monsanto Bayer in regards to the Varroa product or the development of. And so anyway, I watched him give a talk, or I had him give a talk in St. Louis. And he went through and basically on talking about mites and treatments and things of that nature, talked about the mite and kind of give a basic breakdown of the mite, what they do, reproduction, et cetera, et cetera. Talked about multiple different treatments, their thresholds, where they're good at, where their strong suits and their negatives were. And then he said toward the end of this presentation, and occasionally you'll see people take their phone out, take a picture of a slide, make notes, things like that. But the one thing he said to me that will always stick in my mind, and some of these guys have probably heard this story before, he said, okay, for all of those of you that like to be told what to do, this is what I do. And Zach, I'm going to tell you, most of these folks are backyard beekeepers, and I'm not throwing any rocks at them by any imagination. But the point of the story is most of these people at that point in time, my head picked up and I looked around the crowd and I watched them from the back. I'm going to say probably conservatively 60 to maybe as much as 70% of the people, their heads went down to the notebook or they came up with the phone and they took pictures of the slides, which tells me there is a vast majority of these folks that like to be told what to do. So It is what it is, you know?
Yeah. But Tom, I think the way he said that's kind of perfect. I'm not going to tell you what to do, but here's what I do. That's such a good line.
Right?
That is such a good line.
It's how you coach somebody without telling them, right?
Yeah, definitely.
Yeah.
So you can start your slides or your presentation anytime you want to, Zach.
Well,
Hey, Zach, before you do that, tell them a little bit about what you're doing with the new Bee Lab, your goal behind that, and the funding that you need. There's a lot of folks that will be coming in and out, and they may not stay on late because they got to work, but let them know. And I talked with Zach at length about this, and Zach has always been a skeptic to ask folks for money. It's just not who he is. And I pushed him hard, and I said, look, you need to think about this differently because what you're doing is helping beekeepers. And I would much rather, instead of you out there, you know, trying to grab money for your research, let folks know what's there, what the need is, and people who get this will understand. If the funding comes in, he doesn't have to waste his time asking for money. He's just going to get what he needs so he can do the research. There's other people that are better at raising money for him. I brought it up at the Pennsylvania State Beekeepers Association, and just because I brought it up, they allocated $20,000 just in the research for this coming bee year, this coming calendar year. Now, I don't know how much of that money is going to get allocated to Zach. Some of it better. I'm going to raise a stink at the summer meeting, but all that to say is, you know, I told Zach if every bee club out there would reach in their pockets and give some money, all the state association gives money, within no time at all, he'd have all the funds he needs to facilitate that facility, which, you know, it advantages all of us because that research, like I heard in South Carolina at that show, that enables him to do that and gives him the tools to do it. It's like saying, Charlie, you know, I want you to rebuild my engine, but Charlie don't have any wrenches and sockets. I mean, you know, he's got a long way to go before he can even begin to do the work. And that's kind of where Zach's at now. So just kind of give him a little idea where you're at and what you've raised and what people can do to help.
Yeah, I will do. And Rob, so everyone should know, Rob was actually good. He didn't scold me, but he did call me up and for an hour at night, tell me what I should be doing and kind of opened up my ideas. I think the best description is, you know, years and years and years ago, I went through divorce. And when you're going through something like that, you're so stressed, right? You're impacted. You can't give yourself advice, right? But any friend could be a good consultant, kind of give you a heads up. And I actually took that with me and realized that when beekeepers are super stressed or anyone in your life is super stressed, they're not the best to give advice to themselves. And Rob, serendipitously with it, was that person for me a couple weeks ago. I've been really stressed about funding. I mean, everyone in science is right now. It's been, we've had a lot of disturbances in funding for science. And for people like me who haven't scored a permanent position yet, that's a big deal. It means that your salary is not going to be covered, or you might not be able to continue your research. And guys, one of the most vulnerable things I can tell you now is I just will not give up research. I love this so much. And I never actually expected to get here, right? Like growing up as a kid, I always thought of being a scientist and didn't have parents who had a college background, didn't know what it meant to actually go to school and make a career of it, right? And then I had a 10-year gap between my school. By the time I figured out how to actually get into grad school, then it's like, okay, how do I get good at this? How do I become a good researcher? And then after a while, I'm like, oh, I am good at this. I actually can make discovery. And then through the course of this work and working with really great people and great leaders like Judy Chen and Jay Evans, you start to get really involved in important work. And it's the thing that I hold the most precious, the close to in my life to myself, right? So, I've essentially been scared for a bit this year. Now, so what ended up happening was earlier in the spring, my contract could no longer get renewed. I'm not a federal worker. I'm just on these year-to-year contracts working as a postdoc. And that's the mechanism to hire me where I work. And, I started calling around to a bunch of labs who previous years were like, hey, call us if you're looking for something. But they're all dealing with financial instability. So they're like, oh, sorry, we don't have anything, or we're not hiring. We're not going to be able to hire. And I kind of freaked out. So I interviewed for a job in Australia, and then I applied for the job in Canada. And after I did that, my girlfriend goes, I'm not following you to either place. And so we had a conversation that night, which kind of woke me up because, of course, I've been stressing about me and not necessarily considering, if she was on board with moving. And we had a long conversation. The next morning, University of Maryland, Baltimore County is a school nearby, and I've known about it for a while, and I know they have a big, robust biology program. And I just cold called them. And it took them a couple weeks to get back to me. But what they had done is they looked me up online, and the department chair did, and they had this lab space because one professor had gone from research and lecture to entire lecture. And I actually quickly interviewed. They called my references, and I came in and gave a seminar and was doing multiple interviews. And during the whole process, I had actually only asked if they had capacity to take on an independent researcher, and realized in this process that, yeah, they're going to take me on as a visiting researcher. And I'll be able to continue my work, but this is potentially going to lead to a permanent position, and that's the intent there, which really blew me away. So University of Maryland, Baltimore County, so we'll just call it UMBC to keep it short, going forward, did me an incredible favor. But they're taking budget cuts this year. So they're like, we can take you on. Here's your contract. You have access to all department resources. You're on the graduate school faculty. You can take students. But they don't have funding for my salary or for startup. And I was like, well, I'll grant write like a beast to figure out my salary. But if we can raise funds for the equipment and the startup of the molecular lab, that's what I'm doing right now. And so in this lab, what I'm going to be doing is continuing the work that I'm doing. So the Varroa and virus research for beekeepers and mitigation strategies, while also providing diagnostic services regionally for beekeepers.
How much funding have you received so far, Zach?
So as of right now, and I'll share this at the end, but we are at $31,985. And this came largely from bee clubs and some individuals. So the Maryland beekeepers and the Carroll County beekeepers right here in Maryland, they took about 2 seconds to decide if they were going to donate, and they raised $20,000 of that. A couple other clubs that I had reached out to, same response. The New Hampshire beekeepers and the Seacoast beekeepers, I think it took them about 2 seconds to make that decision as well. In fact, they bought our first piece of lab equipment, which I'll share at the end. And then some individuals. So we've had, I see one of the growers that I used to work for up in New Hampshire, who has these commercial greenhouses. He made a donation, which was awesome. Randy Oliver made a donation, and a few other commercial beekeepers. So, and Rob, that was the correct thing. I'm not asking for money. They're making an investment to a lab that's going to provide services, and they want to keep me in this industry. So that was the real way to look at it. Let me go ahead and share so we can give some people some cool info if they haven't seen it. But someone has to tell me how to share my screen. Oh, do I hit the present button?
Yes.
Yeah. So slides and PDF, that's what we want to do. Let's go to share screen. Okay, does everyone see a bee?
Yep. You got to click
oh,
on it.
Do you see
Bill,
a
you might have to promote that.
Do you see no, you don't see it. Okay.
You got to share it, Bill,
I haven't seen it come up yet.
at the bottom.
No, it's not come up yet.
I think Zach's supposed to be share screen. I think it is.
Yeah, he's got to
so
share his screen.
Click on
got it. So, no, I just figured it out.
Yeah, hit the little plus button and you should get a
Yeah,
pop.
plus button in the screen, and then you pick what. There you go.
There we go. Okay. You all on here can interrupt anytime you want. I can't really see anything right now, but as long as you can see UMBC and a couple bees with a lot of mites, we're going to be good.
They're
Yes.
good.
Yeah, we see your screen.
Okay, fantastic. So what I'm going to do then is talk for about 20 minutes on Varroa and viral transmission. And it's a overview of the work that I've been doing with some really great information. Now, this whole talk you'll be able to get online at the end. I'm sorry, this whole talk is about an hour and 40 minutes, which you can find on YouTube. But for right now, I'll provide some really good information here. So as you everyone heard, my name is Zac Llamas. I'm a visiting researcher at UMBC, and I run the disease ecology lab there. And namely, what we study is we study how Varroa destabilizes a honeybee population. We start with this at the individual level, and we grow it out so we understand how mite feedings on individuals causes loss at the community level or the whole colony level. Now, I actually need beekeepers to take this part pretty seriously. And I have a firm belief that to become a really good beekeeper, you have to become a disease ecologist. Our bees are exposed to a lot. And I talk about honeybee diseases more often than I talk about any other subject. That does not take away for the impacts of pesticides on our bees. Pesticides do have impact on our bees. Sometimes it's not acute, so we can't observe it. And sometimes it's not there. But in addition to other stressors like nutritional stress that our country is dealing with, like abiotic stressors like pesticides, we have a prevalent pressure on our bees, and they are harboring lots of diseases. The one I happen to study are the viruses vectored by Varroa destructor. And they are incredibly impactful on our bees. Now, the thing I like to point out right here is that bee right in the center with the crippled wings. That tends to be the bee that backyard beekeepers, and in fact, most beekeepers pay attention to more than anything else. It's an individual that's exhibiting a morbidity. That mite parasitized it during its larval to pupal development. Virus migrated to the pupa's brain. And as a result, this bee has a deformity, usually a shortened abdomen and crippled wings. That's how we get deformed wing virus's name. We pay attention to it because it stands out from any other bee in the colony. I don't pay attention to it very much. I don't research it very much, and it's not of a huge interest to me. The reason being is that individual is going to live a short period of time. It's going to walk around in the comb, it's going to beg for food, and then within a couple days at the most, it's going to die. It's not going to have very much contact with its nestmates. It's a poor candidate for secondary transmission. However, I will talk about going forward the individuals that I pay attention to a lot, and they're the bees that'll surprise you why I pay attention to them. So we've been talking, and I said I modeled a lot of my research off of mosquito biology. There is a wealth of information in vector-borne transmission because of mosquitoes. They vector some of the most destabilizing pathogens on Earth for the human population, namely malaria, which causes hundreds of millions of cases a year. Malaria will dramatically change your life outcome. if you acquire it and if it cannot be treated. So we invest a lot into malaria research and mitigation strategies. As a result, how pathogens, whether it's a bacteria or a virus, move through host populations from mosquitoes is widely studied. And so we have a lot of wealth of information that we can garner from these. Now, I'm getting beekeepers to say this line over and over. It's not Shakespeare, but who a vector bites matters. Meaning when a mite is feeding on its host inside of a honeybee colony, which host it feeds on is predominantly important. And for years, we've had this brood-centric framework for Varroa destructor. What do I mean by brood-centric? So pictured over there on A, we have mites that have invaded a larval cell. Someone tore open that cell and we see this L5 larvae that's already turned over. Mites are on it. Meaning we've studied most mites as how they feed during their reproductive phase on brood. We've also predominantly studied them as C, which is on morbid bees. This is not what I study very much. What I study them on are adult bees and bees without deformities. Now, all the way over on the right there, I've got a worker bee right there with 2 mites on it. I'll talk about this going forward, but those mites didn't start out on that bee. They actually moved onto the bee, went underneath it, went up in between asternites and started feeding on that adult host. They'll feed for a period of time and then they'll leave that bee. That bee right there will continue on its merry way, walking around the comb, interacting with nest mates, taking care of the queen, rearing brood. That's the bee I study. And in most disease systems, this is the host that causes most secondary transmission. It's called an asymptomatic carrier. It is infectious, it harbors a pathogen, but it's not exhibiting symptoms. This is the equivalent, y'all. I don't know what you're like when you get sick, but there always seems to be someone that gets the flu, barely has symptoms, and they show up to work for the whole week. That person's a nightmare in an office setting. They're going to spread the flu to everyone, right? Whereas someone that gets real sick and stays home, they're great for the office. They're not going to transmit to anyone. And that's why I study that worker bee over on the side a lot. Now, I said who a vector bites matters. It turns out there's seasonality to who mites are feeding on in a honeybee colony. And I got the 2 pictures right there. So early in the season, it's already been well established, and we know this very well. Mites like to feed on adult drones. They feed on them by proportion of the population more than any other bee. However, our drones in a colony are seasonal, right? They're going to produce a lot in that early spring buildup. They're going to produce them a lot during the main flow, and then the production slows down as we enter a dearth. Sometimes it'll come to a complete stop. Well, once their ideal host is no longer available, mites shift over onto these worker bees. And this happens mid to late in the season. It's also partially dependent upon colony strength. Now, we figured this out in Maryland by paint marking bees at emergence. And what I would do is I'd paint mark worker bees and drones, different colors, so I knew how old they were and whether or not they emerged with a mite. And then over the course of 9 days, we'd show up and re-inspect those bees. We'd give them additional colors if mites moved onto them. Over on the left there, that's a boo. He was an intern that worked with me during my PhD. He was incredible. He comes from Turkey, from a beekeeping family there. He's a good researcher. He's an excellent beekeeper. And this isn't a rain day for us. That's my old truck that's parked there. We'd pop up a canopy and we'd hand pick up thousands of these bees, looking at them and recording what mites are on them. Now, when I do this work, I get some really cool information that paints a different picture about what's happening inside of your colony that the alcohol wash cannot tell us. And that can be explained a little bit by this picture right here. So this is a schematic of one of the colonies from that experiment. This is early in the season on July 5th in 2020, and this is in Maryland. Now I've got 3 different colored bees there, worker bees there. I've got the brown ones Those are bees, the worker bees that we've never observed with a mite on them. I've got green ones. Those are bees, worker bees that emerged with the mite. And then I've got these pink ones where they emerged, no mite. But then as we're picking them up over the course of a few days, we'd see a mite move on to them and feed upon them. Well, the cool thing about this work is at the end of the trial, I know how many bees were never parasitized or how many bees were parasitized during development or during adulthood. And that's that schematic on the left. So my alcohol wash for this is 5.1%. So this is a heavily infested colony, right? Anyone should be able to tell you, beginning of July, I don't care where you are, 5.1%, that's high. So this is a heavily infested colony. It's a big colony, but still infested. But that 5.1%, all that tells me is that per 100 bees in alcohol, I find 5 mites. That's all it tells you, 5 mites on 100 bees. What it doesn't tell you is of those 100 bees, how many of them were bit or burdened by a parasite at any given time. Now that's that 14.3% underneath there. Over the course of the week, we can calculate that. When we had a 5% alcohol wash with tons of drones, our workers were parasitized at 14%. That's 8. So it's almost 3 times as much as the alcohol wash. But look at that number underneath the drones. They're bearing the majority of parasites. We're finding up to 65% of the drones in this trial are parasitized by mites. Now, I don't have the drone bee schematic here just to keep this simple. But a thing that's happening here are your drones are bearing the most of the bites. Now, drones have one important job, and that's to mate with a queen not within their own colony. They don't rear the brood, they don't take care of the queen, and when they engage in trophallaxis, they receive, they don't donate. They're a poor candidate for secondary transmission, meaning they're probably acting as a cushion, hiding the impacts of varroa parasitism when they're plentiful inside of a colony. In some ways, we're getting a free ride when our honey supers are on. And conceptually, this is what your colony looks like early in the season, where you've got a smaller number of drones compared to your worker bees, but they harbor more mites. And this is actually what we would call an aggregated distribution in parasites. Now, I said we used to focus on varroa as a brood-centric model, meaning we overwhelmingly study it as a parasite of brood. And I would argue we need to shift. So when a mite enters a brood cell, it's temporarily imprisoned. Okay, it enters that cell, it gets capped over. Short of those bees uncapping that cell, it's in there for 12 to 15 days, which means over that up to 2-week period, you have 1 mite, 1 parasitized bee. Okay, she's going to reproduce, she'll make more mites, but you only have 1 parasitized host. Not the case on bees. Mites are mobile, they move from bee to bee. So and mites have this kind of this weird phenomena that they engage in. Some of them stay on adult bees for a short period of time, so 4.5 days, then they'll re-enter a brood cell, and some stay on much longer, up to 11 days. Well, still, in that 11-day period, they switch on average every 2.5 days. So you can get up to 5 parasitized bees in a shorter period of time. And this is why you'll always have more adult bees parasitized than bees during their development. And that's because mites actively move from one bee to another in order to feed. There's consequences to this. Imagine you're a parasite moving along and you're feeding on a bunch of bees. Suddenly you go back to one, and you get a mouthful of virus, right? Now you become an infectious vector, which means the next bite that you have could have a bigger consequence on the colony. It might kill a bee quicker than it would otherwise, or it could start viral amplification in its next host. I carried out a series of experiments on viral transmission. And these were really fun but tedious studies to do. And we did it because we want to explain to beekeepers where the hot spots of viral amplification are occurring in your colonies. Now, we've called mites dirty hypodermic needles for a long time, but we haven't had great evidence of that. So what I did was I paint marked a bunch of mites. I painted some blue and I painted some orange. It's pretty easy to paint mites. And those blue little particles are over there. That's because at the Bee Research Lab in Beltsville, Maryland, Eugene Ryabov, Jay Evans, Judy Chen, they developed this deformed wing virus that has a couple inserts in it, and it glows blue if we add an enzyme or do an enzymatic process. We only use it in the laboratory, I should say. But what I did was I got it inside the blue mites, and I took one of my really small mating frames frames from a mating nuke that had just recently capped. And I opened up a larval cell, and I forced 2 mites inside of it and then recapped it. I did this to a bunch of cells, and I put it in an incubator for 8 days. Well, when I recovered the mites, I crushed them up. Well, I had them feed on pupa, and then I crushed them up. And more often than not, both mites will essentially become blue mites. They'll both acquire that novel virus, and they're able to transmit it. So when they feed on the same host, whether it's a pupa or an adult bee, that's an opportunity for your naive mites, essentially those control mites that don't have much virus, to acquire virus and transmit it the next time they feed on a host. This is why I talk about not letting your mite loads get really high, because you're giving that opportunity for virus to transmit not just to your bees, but from mite to mite. Now, look, we've developed bees to engage in lots of cannibalization. This is excellent, right? Varroa-sensitive hygiene, hygienic behavior, that helps us out in more ways than just mites. Those bees are able to identify brood diseases like chalk and EFB much better. We like that, but that's not a free lunch, right? And when you get high levels of cannibalization, some of those pupae are going to have infectious levels of deformed wing virus in them. Okay, not all, but some. And when the adult bees chew on those pupa, they're cannibals. Well, that's a transmission route for some viruses. And those cannibals can become infectious. What I showed during my PhD is mites on bee right there. When they feed on that bee, they can acquire the virus and subsequently vector it to a new host. So again, cannibalization can promote virus amplification. Now, this isn't to knock VSH or hygienic behavior, but we just want to be aware when we see really high frequencies of cannibalization, it's not necessarily a free lunch. There can be a consequence. Now, down in C, and this is the one that Rob brought up, this experiment took 2 years. It kept going wrong for one reason or another. One reason it went wrong one time, it takes me about 40 hours to set up this experiment. And when I was coming into the lab, I think it was like it's been a Friday or a Saturday, or it was a holiday. It was the first day of the start of the experiment. I had already invested 40 hours of work into setup. And I walked into the building, and the building was warm. And I just went, oh no, something happened to the HVAC, and the HVAC stopped working. And I walked into the lab, and my lab was really hot. I opened up the incubator. I saw the thermometer, and it was like 40 something degrees Celsius. So that's horrible for us. And I looked at my bees, and they just looked like crap, and a lot of them had died. And I just shut the door and walked out, right? There was just one thing or another getting in the way of this experiment. I was pretty diligent, and what I wanted to see, thanks for letting me give a little background. What I really wanted to see there is, hey, our bees are engaging in trophallaxis. They do this all the time to communicate, to share food. It's essential for bees to engage in trophallaxis. It's also an opportunity for oral transmission of viruses. Now, just because 2 bees engage in trophallaxis doesn't mean they're going to transmit virus. The efficiency isn't that high. But because they're engaging in thousands of these interactions, we are going to get transmission. And what I showed over on the left-hand side is we can infect donor bees with that modified virus. And through a mesh screen in a laboratory, it can transmit to recipient bees. Well, when mites feed on those recipient bees, roughly 29% of them are able to acquire the pathogen. And I moved them onto pupae, and about 19% of them vector the novel virus. So it's not 100% efficient, which is great for us. And that's how colonies can shed virus, because it's not 100% efficiency. But here's a consequence. The virus can spread from bee to bee, and mites can acquire it from those recipient bees. So what we should have as a takeaway from here is high levels of mites has consequences. Your mites can become more infectious. And there's multiple transmission routes where a virus like deformed wing virus can move freely between mites, from bee to mite, from mite to bee. it's not just mites have virus and they're making your bees sick. The virus is can be free flowing through all members of this colony. Now, I'm going to switch over to the next slide, and this is why this information matters so much.
Hey, Zach, before we go there, did I just to put it down on the bottom shelf, did I just hear you say that basically a nurse bee who's infected, when she feeds larvae, then she could infect that larvae? It doesn't necessarily mean a mite has to go in that cell and hide under that brood field to infect that larvae, that it could be actually infected through nurse bees that are infected.
Yeah, so we actually didn't do nursing behavior and looking at viral transmission that way.
Mm-hmm.
So I did these routes right here. And the reason we didn't look at that is, one, someone already showed brood food can be infectious. So we thought that was well done. Two, because we're working with a modified virus, we had very little interest. We had no interest in doing this outside, right? Where we could easily study it. So I stayed away from that route. But you are correct. Bees can become infected without the help of a mite.
Yeah. Thank you.
Yeah, definitely. So I'm going to jump on over why this matters so much. Now, I said earlier in that schematic photo, when drones are present, they bear most parasite burden. Okay, that's really interesting. What happens when drones are not present? So this is that same colony, but it's 31 days later. Okay, so we've had some mite reproduction, we've had some loss of bees, but the big change that happened in this colony, where the drones aged out, the colony stopped making so many, and now there are not as many young bees that are drones, it's predominantly workers. And we see this dramatic shift where this colony went from a minority of bees parasitized. Remember earlier it was 14.3% of the worker bees. Now it's 59.9%. Within a 30-day period, now a majority of the worker bees are parasitized. I don't have it listed here, but my alcohol wash is above 14%. So that's a big jump, right? And we typically see this in August. But this is the take-home message I really need backyard beekeepers to get, because you have the best ability to treat your colonies because you have fewer of them, and really small-scale commercial because you're able to pay attention to your colonies a little bit more. When you see this shift onto the worker bees, when your flow starts to slow down, this is what's happening to them. Those mites aren't going on there and having, a leisurely ride saying, I'll wait until you get around to your treatments, or I'll wait until you get your shit together. They're just actively moving from one worker bee to another in order to feed. This was a 9-day experiment. So from day 1 to day 9, we saw 60% parasitism. Okay. And again, this is a heavily infested colony, but it was an asymptomatic colony. It looked pretty good. At the end of this experiment, even if I treated it, I can't take away those bites, right? I want to treat it. You want to knock down that vector, but I can't take away those bites. And that's a big deal. And that's why that question that was asked earlier with the June and taking the honey supers off and treating when we see it, you want to do it before this, before you see that big shift. So what I really need beekeepers to do is become disease ecologists and rethink how we approach Varroa. This is how we think about Varroa. How many mites per 100 bees? And I need you to think of them more like this, where who are they biting and how much impact are they having on my colony? Now, this full talk can be found here. And this is a QR code that'll bring you to a YouTube. It's also really easy to find. If you type my name into YouTube or my name and drones into YouTube, it'll pop right on up. And it's a great thing to listen to as you're driving. And don't ask me, ask people like Rob how it was impactful on their beekeeping. Now I'm going to make a quick shift, and I promise I won't take up much time doing it, and I'll be ready for tons of questions. But this is the research I do, where we identify how mites are impacting your colonies, and then we start to develop mitigation strategies for it, whether it's management, and I really invest into management that's beneficial for small and medium-sized beekeepers. So if you got 50 to a couple hundred colonies, we really like doing IPM for you. And we also work on therapeutics. So this is what beekeepers have done for the lab so far. And I have a game plan. right? Because this is pretty awesome. So I've been grant writing like a beast this fall. I've been sending off grants for my salary and for students and for our ongoing research. I have some NIFA funds I can transfer later, which is awesome. But I need some beekeeper support to really make the lab work. The most valuable work I can do with your donations or Bee Club support is not through my salary. Once I get a paycheck, that disappears. I don't want beekeepers supporting that. I want you to support the equipment in the lab, because that equipment will have a long lifetime and be used for up to a decade. So I'll talk about it in a second, some of that equipment, right? And that's the most efficient use of equipment for virus and pesticide research. And some people would be like, why would we want to support? Well, look at the work I've done in the past, and I'm just going to point out a couple things. I was first to figure out how to rear queens in the laboratory. In fact, Corey Stevens and I reared queens in the laboratory over here in Maryland. He instrumentally inseminated them, and then we're able to get them without ever going outside to rear brood in the laboratory, right? So this is some novel stuff so that we can start to study gene knockdowns or lower cost pesticide research in honeybees. The work that I just showed you on the seasonal parasitism of Varroa, then there's a lot of stuff we don't talk about. Not because we don't talk about it, we just don't get a chance to. Like, I helped develop miticides. We come up with different methods so that we can deliver products. In fact, we came up with some really cheap methods so we could rapidly screen miticides. I'll do the same thing when Tropioleps eventually gets here. And the other thing, and probably the most valued work, is responding to beekeepers. And I have been able to do that because, again, Judy Chen and Jay Evans at the USDA will reprioritize service to beekeepers. If you're not familiar with it, you better get used to it, because I'm very apt to make UMBT known in the bee world. But this is a gem of a college in our backyard. It's gorgeous, it's cozy. We have 14,000 students, so it's big but small enough as far as universities go nowadays. And it's an R1 institution, meaning it has incredible core facilities and a robust science program. This is 1/4 of the lab space that I have in the Department of Biology at UMBC. And this is an example of what I'm doing with funds. So the Seacoast beekeepers and New Hampshire beekeepers in New Hampshire, okay, I guess that was redundant, but we'll roll with it, right? They each donated $2,000 and $1,000, so $3,000. And they were like, "We're sorry, it's not much of a donation." No, it's an incredible donation. So this is a thermocycler here, and I'm taking a picture. It's actually at night. I landed from California, and I was like to my girlfriend, "Can we stop by my lab? I know a new piece of equipment showed up. I really want to look at it." And yeah, I know it's dorky, and she definitely called me a dork doing this. But I wanted to unbox and look at it. So this is a thermocycler. It's essential for us to do viral research. And what it does is it heats up and cools down at very specific times so that we can convert your crushed up bee sample to a stable form of DNA that we can constantly go back in and test. We can also make clones with it and stuff. That's normally a $6,000 piece of equipment. But just like everyone's going to be going out on Friday to Costco and other stores to get some deals, our scientific equipment dealers are doing deals right now. There's nothing wrong with this equipment. It's not going to get discontinued. It's not old. This is new, but we got it for half off. And this will be used for up to 10 years for hundreds and hundreds of trials. So this is like a really good use of funds. This is my first student, Brenda. She's actually doing an imidacloprid experiment. Once we identify hazards for beekeepers, we jump on and start doing some of that work. So that's why I had her on a pesticide trial right away. And if you're interested, we'll share the URL in the chat on the side, but you can go up to that QR code right there and it'll bring you right to the webpage if you want to donate and support the lab. If you don't want to, if you have a business that needs end of the year, does end of the year philanthropy or your bee club, reach on out. We'd really like the support. And right now what I'll do is pause for a second and then stop the share so we can kind of get back to being a group and chatting. And guys, I really appreciate the time to do this talk. All right.
That was really good, Zach. I think you made a lot of people think.
Well, that's great. I love hearing that. Am I still sharing or am I not sharing anymore?
No, you're not sharing. Roy has another question for you.
Yeah.
Bring us back, Bill.
Yep, hang on. I'm getting there. There we are. We're back. Charlie, you're not.
Mm,
Charlie went after a snack.
Ah,
He went after his popcorn. So Roy has a question for you. He wants to know how many different viruses can a hive have?
yeah, that's a great question. I don't know the answer. So a couple reasons why. And Roy, that's a phenomenal question. As soon as I saw you post that, I actually opened up an Excel file of a large screening I have to look for the min and maxes. And the reason we can't necessarily tell is we only screen for a certain number of viruses in a colony, right? We'll screen for deformed wing virus A and B and ABPV, CBPV. But there's also lesser known virus or variant that we don't actively screen for. So you'd have to do RNA-seq or some sort of metagenomic analysis to screen for the whole viral diversity. I don't have that answer. But I'm looking over here. Okay, here's a weak colony, and it looks like it's loaded. How many different viruses does it have? It's got 1, 2, 3, 4, 5, 6, 7. So there's 7 right there in that one. So it looks like on the high end here, just cursory looking through my data set, 7. So the most I see right here is 8. And that's screening for 9 viruses. Now, most of these are positive strand RNA viruses, and they're ones that we commonly hear about. But we'll also see some lesser known ones that don't show up as frequently. Like there's this DNA virus called AMFV, and we'll see that at low frequency. But that's a great question. I don't have the answer, unfortunately, for you.
Hey, Mike.
Hey, how's it going, Bill?
Pretty good. Zach, this is Mike. He's from New Hampshire.
We had lunch together
Okay.
at the New Hampshire Beekeepers meeting.
Yeah, we did. That was almost 2 years ago now, wasn't it?
Yeah, I'm glad to see your presentation didn't get hijacked like it did there.
Yeah. What do you mean?
You were in the middle of
With
your talk and someone hijacked it and it started to play like adult sounds.
Oh, gotcha. Yeah, I try to block that stuff out.
Oh, that was hilarious.
Okay. Yeah, that's the thing on the internet. Well, good to see you.
I think our club donated to you already also.
I did. If you're just coming on, I was just talking about it. Did you see the piece of the...
I've been yeah.
Okay.
Because I'm with Merrimack Valley
Okay.
Beekeepers. I don't know. There's been talk about, because we doubled what we were going to get you when we found out you were going to start this.
Oh, thank you.
I don't know if it's been sent or not yet.
Oh, yeah, Mike, actually, I just showed the equipment that you all helped me purchase.
Yeah.
Collectively in New Hampshire, you all raised $3,000, and I actually bought a $6,000 piece of equipment with it. Because the company had a fall sale, and it's a new piece of equipment, nothing wrong with it. They're just trying to entice people to purchase. And I was like, there we go.
Do you find the mites are different through different parts of the country? Or do they all carry the same viral loads? I mean...
No, that's a really good question, but I haven't done like a nationwide screening of either the haplotype, because we have 2 different haplotypes here, or I haven't done screening of the viral levels in individual mites across the country. So I do individual mite extractions, and I can tell you what viruses are in an individual mite if I do the work. Yeah. But I haven't done it across the country. That'd be some pretty tedious work, especially I think you should make it seasonal as well. Not just like what's the virus in mites in Texas, but what's the virus in mites in Texas, winter, spring, summer, fall.
Yeah.
Hey, Zach, based on your PowerPoint you just presented, it would seem that doing a mite knockdown before, say, July, when we, typically pour honey supers on and put formic or something like that on, is almost paramount if we're seeing a lot of phoretic mites that are affecting a lot of other bees, as long as because we're finding that the drones are starting to dry up right at that time, and so you see that. So to do them, knock down either an OA vapor or something like that would be crucial, or something else that would work with honey supers on.
Yeah. Yeah, totally.
What is your thought of, and I know this is not, again, your area of expertise, but with this new stuff Nora coming out that's supposed to interrupt the reproduction on a mite?
Yeah, I'm pretty excited about that product. I'm excited about a couple products. The Noroa is one of them, and it's not supposed to replace Amitraz, right? What was Amitraz really good at? It was about knocking down a lot of mites real quick. So you could have a high infestation, it would suddenly drop them all. That was excellent. This is designed to be used in colonies that have low infestations, and it'll help them keep that low infestation for months. That's really excellent. And if we think about our beekeeping, we're getting ready to throw honey supers on, and we use that as a spring treatment. And what we want it to do is to let us ride out that main honey flow without damage to our worker bees. And then when we pull off our honey supers, we can then invest into other treatments, right? So it's not a silver bullet, but I love the idea that we can use that as a spring and then ride out the honey season. And look at what a lot of commercial beekeepers were trying to do this year. They were using extended OA in their colonies, when they moved up to their honey yards. And what they're trying to do is keep that mite levels lower, not let it grow much throughout that whole season. And so I think that product will help, but it's going to probably be paired to something like OA. And I love the innovation people are doing with oxalic acid right now. That makes sense.
So for me, that vessel will only ever have regular cream honey in it. And then
Zach, you plan on going to Bill? What's that called out there in Kentucky? The show?
Nobby.
You going out to Nobby at all?
No, it's not on my agenda. Not because I don't want to go, but done a bunch of talks, and I'm going to HPA and ABF. I got invited, and yeah, I'll probably take a little time to recover. But are you all going out there? Because it looks like one heck of a party.
Yeah. Mike, are you going this year?
Oh yeah.
I know Michael's coming because he's a vendor. I'm a vendor out there. So
Bill takes up half the showroom.
No, I'm not that big. But I'm pretty sure most everybody else is coming. So yeah, it's a big party. We do have a dinner out there for the group, and we all get together and talk and share ideas and everything else.
Mm-hmm.
Bill, you got the donut booth, right? Aren't you near the refreshments?
Yeah, I'm over near the refreshments. Yep.
Oh, don't threaten me with donuts. That's my vice.
Great.
Coffee and donuts, right?
Oh yeah. No, you have no idea. So little backstory. My mom is a celiac, and as a kid I was always getting sick. So they self-diagnosed me as being a celiac, and I went decades without eating gluten. And when I would get sick, I always thought it was some sort of cross-contamination, right? Well, a couple winter ago, it was just getting bad. And I went to my primary care, and I finally got a primary care. I really liked working with her. And I just said, I don't care what I can eat or what I can't eat. I just want to know the yes foods and the no foods. And I was like, I don't care what I do. I'll do a diary. I'll send you pictures. She's like, don't send me pictures. Anyway, she asked me, so you're a celiac? I'm like, yes. And she goes, and you were tested? And I said, yes. Well, no, my parents diagnosed me. And then I just stopped and I went, huh. Thinking of like all the times in my adult life that my parents were evidently wrong about things. And I'm going to be really kind here on that. And so long story, we quickly found out it's fructose. Can't have much fructose, right? So no mangoes, no watermelon. I got to be careful with the honey. Turns out I can't have a lot of onions. But I can go to Dunkin' Donuts, get 24 donuts, and it won't have a thing with me. And for decades, I've stayed thin, partly by just not having gluten. I have no defense against eating donuts now. Like you just put one in front of me and I'm like a child. And I'm trying to make up for 20 years. So at CSBA, they had this gorgeous donut wall, and there were all these really fluffy yeast donuts. Thank goodness it was public, because I would have pulled a fire alarm and had my way with that wall. It was delicious.
So I haven't known a government worker or a government contractor yet that didn't live on coffee and donuts all day long.
Oh, you should really see the bee research laboratory. People are coming in with their quinoa salads, or
I have.
Jay gets up at 4:30 in the morning and goes biking or rowing, and then he comes into work.
Yeah.
I come in with my Dunkin' Donuts, and I feel like the slob. We got people.
I have 1, 2, 3, 4 questions for you.
Okay.
Here. So there's the first one. Zac, if mites are on the drones, are the alcohol washes deceiving? Also, do you have any idea how to test for mites on drones?
Yeah, so this is not a unique idea to me. If you look at older mite research papers where they were trying to quantify how many mites were in a colony, and you also see this like in Randy Oliver's articles, right? Everyone talks about it. We know that the capped brood are a reservoir for mites, and that capped brood area is variable between colonies and across seasons, right? So fundamentally, we've known that there's an issue with the alcohol wash and that it can't be an absolute quantification. And older papers always tried to pair the alcohol wash with some like capped brood surface area to give you a better estimate. So we've known that there's been an issue with the alcohol wash. I will say the alcohol wash is the current standard method to communicate from E to U and vice versa how many mites are in our colony. So everything I say after this, I don't want you to throw the baby out with the bathwater. It's still useful. But early in the season, it doesn't sample for what we ask it to sample for. Mites are predominantly on drones. Our colonies are huge, and there are fewer workers by proportion on those worker bees. The alcohol wash is designed to collect nurse bees. So you're missing a lot of the drones because our sampling methodology is designed to sample one type of bee, the nurse bee. That's why you grab a brood frame with capped and open from the center of the brood nest, right? Whereas they're predominantly on those young drones. Now, later in the season, the alcohol wash is excellent. Those mites, those drones start to disappear. You have a more homogeneous population inside of your colony. The alcohol wash is finally sampling for what we asked it to sample for. But in some ways, you're sampling for apples in the spring and oranges in the late summer and fall. So I would take those early season zeros or ones. A lot of people like to say no mites, no detection. That's what it means, right? So, and we don't have a great alternative right now. And that's why I say don't throw the baby out with the bathwater. I do repeated sampling on adult drones. You'll see me do this hand picking. And in Maryland, I'm behind on publishing. We got to work on publishing this. When we see multiple detections on adult drones, we'll pick up 40. Back in April or May, 100% of the time that's heavily infested in August, right? So that's for us is a great predictor tool that we're using. The problem is it's not super practical for people that got tons of honey supers on, and maybe it's not representative of all of the country. But there are some alternatives, but we got to figure out how to come up with them.
Zac, am I correct in saying you're a huge advocate of drone comb removal?
I love drone comb removal. Absolutely. From a disease ecologist perspective, it's excellent. And think of it this way, you're actively removing mites before they get to reproduce. That's phenomenal. You're actively moving mites before they feed on your worker bees. You're not adding a chemical and getting a confounding effect, exposing your bees or contaminating your comb. That is awesome. Also, production of wax is a great way for bees to clean themselves, right? You're culling that wax out of there. I love it. I really love it. The other reason I love it too, especially the scale a lot of people are working here, you're doing that drone comb removal in your brood nest. So when I did this in Maryland, I'd show up and I was just on a 3-week schedule. And the first thing I got to do is pull off my honey supers. Well, sometimes those honey supers are full. Okay, so I pull them off. They're real heavy. I pop out that drone brood, knock it out, put it back in. I under super, put my heavy supers back on top and go down the way. You can make more money doing drone comb removal because you're actively either harvesting honey or adding more supers when needed. I love it. I love it.
Okay, next one. Any research being done to develop vaccines against the more common viruses?
Yeah, there is. And there's some really great researchers across the country doing this. So one of them I still work for, which is Jay Evans. Again, I'm in his postdoc and my contract's through February. But Jay has been trying to develop antivirals for years for beekeepers. And he's taken a really great approach on how he wanted to pursue this work. And he's thought about this culturally too, right? So, and practically. So any antiviral has to be able to move through the regulatory process pretty quickly. There's no point in us developing an antiviral if it's going to be held up for 10 years. The next is it has to be affordable, right? It has to be cost effective for you to buy it and put it into your colony. And it has to be adoptable by beekeepers. So natural products are kind of ideal because they're more likely to be adoptable by beekeepers, inexpensive, and move through the regulatory process pretty quickly. And he's been screening natural products for their antiviral properties in bees. Some of the methods that we come up with and use were actually to streamline that process. So this is why we went from screening a handful of compounds a year to now, Jay, I think he's doing like 130 trials a year or something like that. It's incredible. And the reason that blue virus I showed, the original use for that, is it's cheaper to do an enzymatic process looking for that blue virus than it is to do qPCR. So Eugene and him came up with that so that they can do the viral screening pennies on the dollar. Now, Jay's not the only one. Michelle Flanagan out at Montana State, if you're familiar with her work, developing antivirals. We also know that Dalen's getting into that as a private company into that space with an interest. My work and Jay's is starting to converge more and more. Jay's developing antivirals for the whole colony. I've been kind of pestering him. Hey, I'm studying these individual transmission. Wouldn't it be cool if we just develop an antiviral that targets a specific transmission? And so this year we had a really big queen finding, hoping Bill has me come back around to share it with everyone here. And I'll explain then why we're specifically want to develop an antiviral for that route. It'd be real interesting.
Next one. When a good flow happens, we see brood diseases drop. Can you touch on what's happening at that time?
Mark, if I had that answer, I'd be so happy. I really would. Brood diseases, I mean, they're so fascinating, but they're such a hassle. And I don't know why they flare up and disappear. I wish someone really had an answer for that work because we could understand how bees are either harboring a commensal infection or if like the comb is a reservoir for the pathogen. I'd love to know that answer. And bring someone on smarter than me to tell you the answer there. That'd be great.
Is it true, Zach, that a lot of these viruses maybe flare up because of environmental stresses? You know, if you're growing poor nutrition, the bees are on the dirt, stuff like that. You know, be the same as, you know, we put Charlie on a non-popcorn diet for about 4 months.
There would be no
that,
living
Rob.
with you if you did that.
Yeah, that is hysterical. Now, so we'll explain one thing, which is a narrative on how, like an environmental exposure is increasing viral abundance. So some pesticides will tie up important immune pathways in the honeybee. And when that happens, the bees have less of their innate immunity to suppress that viral replication. So some of those are these things called like the toll pathway, right? They make these small proteins, these antimicrobial peptides that help in their immune response. And we also see that they can block these nuclear factors that are important in AMP signaling. I think that was like a PNAS paper. So that is where the underlying narrative is that they're essentially tying up the bee's innate immune system, and then viruses can replicate at higher levels. Hopefully that answers the question that you asked as a broad overview.
Okay, two more.
Hold on one minute, Zach. I want you to back up just for 1 second. I know you didn't. I don't think you've specifically studied this, but you hit on one thing earlier about potential poisons, herbicides, pesticides, etc., in the comb, and if that plays a significant role in potential viral issues. Can you give us your thoughts on that? Again, I know you haven't studied it maybe specifically, but maybe give us your thoughts on that.
Well, no, it's something that we're interested in. So, like I said, my lab, and where I am at BRL, we're interested if it's causing harm to bees, we're interested in it. And comb is considered by beekeepers part of their assets, right? Well, one reason BRL is just so successful as researchers there is we have really fun conversations. And one of those conversations we had is, when is your comb an asset and when is it a liability? And that last part was a big question this year with commercial beekeepers, with literally hundreds and thousands of boxes of dead out comb. And they wanted to know, is there something in there? If I buy bees, am I throwing good money after bad using that comb? We couldn't come up with that answer right away. And us and collaborative university labs haven't come up with it yet. Now, we know from pesticide screening that our comb will harbor a lot of pesticides. Most notably, beekeeper applied miticides. Those are usually the highest levels. And then followed by fungicides. So we see those for both diversity and the concentration at the highest. How it impacts viruses, I don't know. And that's a tough matrix to study, because you might detect something in comb. Doesn't mean your larva is actually in contact with it, actually like in the surface of it. But that is a big deal. We can also, like, I can do an RNA extraction off of comb and tell you what viruses are on your comb. It's far more difficult, though, to actually study, are they infectious? I would like to see better research in it, because to me, this is like no-brainer research. Mm-hmm. Beekeepers are reliant upon making splits in the spring to recover from the winter losses. By and large, that is true. Mm-hmm. And we really should study these bottlenecks in our industry, where certain things like comb, like queens, might have an outweighed impact on colony survival or beekeeper profitability. And to me, what you just brought up right there, that's beekeeper profitability. Am I better off melting it, or am I better off using it? And give me an answer,
Yeah, 100%. And I know this gets regurgitated a lot, because it's the absolute truth is the comb in a colony is an asset, but there's the big question, but at what point in time are there diminishing returns on hanging on to it? And that's probably kind of a answer that you would probably say it depends. So maybe a per colony basis or a per issue basis. But it's kind of like that question that if we could answer that, we could probably solve a lot of issues with it too. And knowing when to take that comb, pull it out of the colony, burn it, whatever the case may be, melt it down, give the bees new, fresh foundations to redraw it out and promote better health within the colony.
Mm-hmm. Absolutely.
Next question. Then we got one more after that one, and that's going to be the easiest one, I think, for you to answer.
Well, I want to try to squeeze one in if I can.
Huh?
I want to try to squeeze in a question at the very end if I can.
Okay. When you talk about disease ecologists, what talk goes deeper into that subject?
What talk? I mean, a talk I've already done, or?
I'm assuming so, yes.
Okay. Well, that one on the SBGMI is a great one to get deeper into that subject with honeybees. In general, you can find great books on disease ecology. For example, books on the plague, Black Death. Those are often excellent narratives that can describe the interaction and evolution of a pathogen and how they interact with a host society. So if you just kind of want to get more into that general area of science, disease ecology, go to my talk if you want honeybees. Really, if you want to see some cool narratives, look up, I'm trying to think of a good book on the Black Death, because they interact with human societies and really get a bit out of that.
And Uncle Junior wants to know, where does the mite live before it hits the hive?
Well, unless if Uncle Junior has information I don't have, they're an obligate parasite. meaning they have to be on a honeybee in order to live. So that means either in the brood or on an adult bee. And we don't have any evidence that there is another reservoir host for honeybees. So kind of before they hit the hive isn't a great way to put it because they're always in a hive.
All right, Michael, go ahead.
And so I was just wondering, have you or do you know of anybody who's done like viral load research with treatment-free beekeepers? I'm asking because I'm and not just treatment-free, successful treatment-free keepers to see what the viral loads are in their hives compared to the standard methodology of keeping bees. And I ask because like I've been doing treatment-free for over a decade. I've been keeping bees about 13 years. I run 20% drone in my hives year-round to where they lay year-round. I don't freeze. If I take mite counts, depending when I take them, I can have them in the 70s, and I run about a 5% loss rate year over year on average.
Okay.
So I was kind of curious if anybody's looked at like what our type of viral loads look like compared to others, and are we running higher loads and we've just got bees that have by chance adapted to it better, or are we actually running a little bit lesser viral load, or if it's basically the same? Or
yeah. So, I mean, I think we need specificity sometimes from someone's operation. Like I've known treatment-free beekeepers and treatment beekeepers that'll quote like a low loss, but they're creating a lot of replacement colonies within a year to keep that number stable, right?
Sure.
And so there's some missing information on just how to keep those numbers even. And I don't think they're purposely trying to be misleading. But the fact is, most beekeepers have to produce extra colonies in the year just to have the same number from January 1st to December 31st. So I think kind of getting some background and maybe the attrition that's occurring in those colonies is helpful. But I've seen it both ways. And this is not science. This is just kind of my thoughts that have fully formulated. I've been in some treatment-free beekeepers who don't let their colonies crash. So they are doing management that's effective to a treatment, usually brood breaks and splitting, right? They're not letting colonies crash, and they'll cull yucky colonies. You know, stuff that's starting to get beyond, they'll cull it. And I think that is a necessary. And I've sampled their bees, and I'm like, are you kidding me? Like, just not seeing viral levels. I mean, they're getting detections. We're just not seeing these high levels that I'd assume to see with that many mites. And then I go into someone else who's treatment-free, and they're not engaging in some of that management, especially like the culling and not letting things crash. And we're seeing high viral levels. We see mites, we see high viral levels. Okay. Now this is not science, this is my belief. I do believe there's a benefit from mites having low viral or low mite pressure consistently, right? And I think there is a transgenerational benefit. Proof to that? No. But I've been in some of those operations and I'm like, man, there's got to be something to this. The other thing too is a couple operations I've been in who were just great at treating, and then their amatraz didn't work. And I mean, their mites or their bees just drop with mites. And I am curious if it's because they just didn't have that low level pressure for a period of time. Yeah. And I'm wondering if it's beneficial, kind of that epigenetics or that transgenerational. I don't know, but I think there's something there. And the person who's going to be a far better expert than me on that whole conversation, and if you all haven't checked him out, you should, Stephen Martin. He's got a great talk online and doing some really good work. Michael, you probably are familiar with him because of the treatment-free stuff.
I was just wondering if any of y'all would be, curious the people like us to, take some samples of drones here and there and send it to certain people to let them kind of see what kind of stuff ours has compared to just the general beekeeper and see, just out of curiosity. I didn't know if anybody even was curious enough to even spend the time and money on something like that, or if it's not worth the trouble.
Well, if we have funding, a lot of stuff's worth the trouble. But I would kind of always think of what can be the impact. Can I have an impact on you? You probably have some diversity of colony conditions in your operation that you might be interested. What's the viral background on those, right? That could be useful to you. Doing the treatment comparison just gets noisy, right? We need to have a lot of samples to get statistical power. and then it gets cumbersome and big real quick. So I think that's largely the reason it's not done. But also, what's her name? Help me out here, Rob, because I'm bad at pronouncing names. Uribe up in Penn State.
Marguerite.
Yeah, doing a lot of that good IPM and organic treatment work might be more aligned with what Michael's talking about. I know they're still treating, but kind of more aligned in that IPM, not constantly treating, might be a better voice for that.
Yeah, she was up there, spoke at the conference here 2 weekends ago, which actually I asked the very question that someone else asked here. They came back and looped around about the environmental. The varroa mites live in any other environments besides bee colonies, and I actually asked the question up there to them regarding to honeybees. Do they host on any other types of bees? And they said no. Apis mellifera in the United States are the only species of bees that are affected by the varroa destroyers.
Yep.
Michael, can you elaborate on what you said there about your run 20% drone? And what part of the country you're at?
So I'm in Arkansas, like basically Arkansas, Oklahoma border, right on I-40. So like right in the middle of the state, like I'm on the borderline. So for years, I run 20% drone frames year round, and I don't pull and freeze them. I've always let them hatch. I always have drones in my hives. I put them in the boxes to where they don't always will go. You know how they'll go and backfill when they decide it's time to stop. Well, I'll purposely move one over sometimes to get it close enough in the brood nest to where they don't like to break the brood nest, so they will just keep laying drones in them. And I don't pull them and freeze them because I would rather just let them go. I figure the higher the mite numbers I have, I'm giving basically targets for my mite to affect them since they prefer the drone. That's just kind of how I've always run it. And I know that's different from what most people do. And I know by not taking those frames out and freezing them, I'm not getting those infected, viruses that might be on those bees out. That's why I was kind of curious if, somebody like me, if we have higher loads and our bees have kind of adapted to it, or if we just don't have as high of a load, or having that low level pressure is helping kind of keep them in check, I guess. I don't really know a good way to put it.
So does your brood nest shut down at all in the winter?
Yeah, so that's the other thing. So I use Russian bees, and I've been breeding my own bees for 12 years now. I don't bring in outside genetics generally. So I've, over the time, first few years, it was rough. You'd lose 80-90% of everything. And things, as things reproduced every year and adapted, I would just keep, breeding them. So I've got my bees now to where, so my Russians are really, really heavy propolis producers, and they're super conservative. So this is probably, I know this helps a lot. So in the summertime, all of mine will actually stop laying for a good solid 2 to 3 weeks. It looks like they're completely queenless. They just stop in July when our dirt hit. And then they'll explode when the fall flow comes in. So I get a nice break there. And then in the spring, when I'm coming out, just because I don't want to have to manage them real hard, I go in and I artificially swarm every single queen I have in every single hive, regardless of age. So that gives me a secondary break. So between the two hard breaks and running all the high drone percentages to take all the damage, that kind of works out for me. But I've always just been curious how that translates to viral load, because I'm getting breaks. I'm knocking. You would think I would knock mite numbers down, but when I would do washes, I'm such a high number. I obviously have a lot in there, so I'm just kind of curious. I obviously have a lot in there, whether they're affecting the drones or not. So what kind of viral loads is somebody like me actually running? I'm just kind of curious if I'm running a super high viral load and they're handling it, or if I'm just kind of running a viral load that's pretty comparable to everybody else. I'm just curious. I don't have a way to be able to tell that.
I would just work with your extension or your state university, see if they could do diagnostic services for you, so you can have a benchmark even for yourself. That'd probably be the way to go about it.
Yeah, I know the guy here at the U of A that head of that. So I never even really thought about asking him to look into it for me. So he might be curious about it. I'll get a hold of him and see what he thinks.
Well, we'll definitely check because they might actually have funds to provide services like that, not just because of colony loss or something, but they might have funds for screening and diagnostic services, in which case utilize them.
All right.
Okay.
Last question, because it's after 10. All right. Has anybody done research on fresh beeswax versus old beeswax, and if they have any effect on the varroa count in the hive or the health of the hive with lots of varroa?
I don't know that one. If there's a difference between fresh and old beeswax, and then kind of health of the hive is a pretty broad measurable, right? So we do know that newer wax tends to have less pesticides in it, but whether or not it has an effect on varroa levels, I don't know. I would generally cycle out your wax though every few years, and I think that was one of the best recommendations that came out of BIP, was encouraging beekeepers to do that.
Yeah. Well, everybody, it's 8 minutes after 10. I'd like to thank Mr. Llamas for coming on tonight and let him know that he is welcome to come back anytime he wishes. And I'm sure that if you guys have input in the future as to what you're seeing in the field, or help him with a research project or something like that, I'm sure he will entertain that with you individually. So if you like tonight, smash that like button. And if you haven't subscribed yet, please do so. It keeps us all hanging around for a few more weeks. And thank you, Zac, for coming on. I really appreciate that.
Yeah.
Bill, I noticed that Zac had put in the private chat the link to where people can send donations. Is there any way to throw that up on the screen for anyone who's out there watching? And I'd like to make a donation to the Bee Lab there to support Zac.
That should be showing on Charlie's screen.
No,
because it's not showing on mine. Comments.
It's in the private chat.
I don't see a private chat on my screen tonight.
Oh.
Yeah.
Do you have it there somewhere else that you can put it up?
All right, there it is. There it is. It's in the chat.
Yeah, it's in the chat.
It's a different place to add it. Gotcha. Cool. Yeah. Oh no! Don't restart me.
No, I'm not.
No. My computer was. I was about to have the worst Irish goodbye on a podcast. I was like, man, these guys are gonna think like 10 minutes after 10, and you just no. Yeah, if it can go up, that's hugely helpful for a lab. My continued research and success is dependent upon beekeepers and clubs. We've definitely had that so far, and people like Rob and Bill coming out as advocates for the lab is super helpful and also much appreciated. This has been a really tough year, both with workload and other things, and the beekeeper support, whether you all think it matters or not, it really matters. It really does. So.
Yeah. So if you text me that link, I'll put it up on here next week, and I'll put it on my Facebook page as well.
I appreciate it.
Zac, how is your schedule as far as to go to local beekeeping groups and do presentations?
It's getting a little tight right now. So NEFA extended their grant deadlines December 8th, and I have to finish this really big grant. And that's for the ongoing funds, like the research, right? And so this is an opportunity to bring in for my lab about $425,000 over 3 years, right? So that'd be my salary plus research funds, and that'll largely be for studying antivirals in a specific virus route. So I'm kind of putting all my time into that right now just to get it submitted. And then after that, I'm pretty open. You know, if you're in Maryland, you know that I stop in at local clubs. And then I'll make my way to other clubs. I'll have to tone it down for a point at some point because I need a break. which is good. But give me a holler.
Okay.
Definitely give me a
All
holler.
right. Thanks, Zach.
Bill is in your messenger.
All right. Thank you.
Zach, do you think you'll be heading up to Troy's this next summer?
I just stopped up at Troy's, chatted with him in his honey house for a couple hours. I wanted to see Timothy, the new baby, but he was napping, and I didn't have the heart to kind of bug Patty about that. So I got to go up just to see the new baby. But we stopped that trial. It was 4 years, and it was a good stopping point for that trial. And what we really need to do now is finish the extractions and finish doing all the raw data so we can eventually put that out. But that was Troy's excellent, as you know, and that was a great project.
Yeah, he put on a Harbo thing for the Hampshire beekeepers that I attended this summer. It was fantastic.
Awesome. That's good to hear. Man, I'm glad he had the time for that because he's picking up a few new yards, so he's really humming when he gets going.
He picked up a nice new place too. His new building.
Yeah, right beside.
So I'll
nice
see if I
meeting
can get you down here in Virginia on Zoom for a couple bee clubs as well.
Yeah, that'd be great.
Down here in the valley. So, well,
I'm
thank
gonna
you.
get going. Thanks, Bill.
Yep. Thank you, Michael. Thank you, everybody, for coming in.
Yeah.
Everybody here knows to hang around. You can get in the green room. So if you want to hang around for the green room, you can too, Zach. All right.
Okay. Yeah, I'm going to tuck her off and get the rest of dinner. But guys, it was great meeting everyone. Bill, Charlie, Rob, thanks for the invite, and good to meet everyone else.
All right.
Thank you.
Thank you, Zach.
Thanks, Zach.